Good evening, sir.
Good evening, Mother.
Yes, sir. Just I will make you as a host, sir. Then we will start.
Yeah.
Sir, shall we start, sir?
Just a minute. 1 minute.
Okay.
Mother, you can start.
Yes, sir. Very good evening, all the participants. Today we are in the second session, second day's first session of the online ATAL FDP, which is sponsored, funded by the ATAL. We are conducting this FTP in association with the mechanical department as well as the information technology department from the Nutan Maharashtra Institute of Engineering and Technology on the topic of the emerging trends in the renewable energy, smart system, and the climate change mitigation. So today, for our first session, we have the eminent personality with us. So just it is time to introduce about the today's session chair, Dr. Kumar GN sir. About sir, currently sir is working as a professor in the Department of Mechanical Engineering at National Institute of Technology, Karnataka, Surathkal, Mangalore. Sir is also worked as associate dean, and currently sir is holding as in charge of registrar at NITK Surathkal. Sir has completed his PhD from IIT Delhi in 2011, MTech from the KREC, currently it is NITK Surathkal in 1999. Also, sir has completed his BE from Bangalore University in 1996. Sir is having more than 23 years of experience in the teaching as an academician, as a researcher. Sir has the different research areas. He is interested in the different research areas like alternative fuels for IC engine. Also, he worked on the simulations of the IC engine, heat transfer, even for the hydrogen fuel also. Sir has got the different fundings. So out of that, just I will say the one that is the study on low temperature combustion in CRDI engine using the biodiesel, which is from the DST Government of India. Sir is having more than 60 plus international peer-reviewed journal papers on his name. Along with that, sir has published more than 100 plus articles, papers in the national and international conferences. Sir has delivered more than 50 plus invited lectures at various conferences as well as the various institutes, reputed institutes in India. Sir is having more than 20 plus book chapters on his name. Sir has guided more than 16 plus PhD students at NIT Surathkal and more than 15 plus MTech by research students and 50 plus MTech students along with the more than 20 plus BTech students. Sir is having the very good citation. He is having more than 2,200 plus citations on his name, and sir has attended the different conferences, national and the international conferences regarding the IC engines, like NIT Calicut, SVNIT Surat, even UPES Dehradun and the NIT Surathkal. Also, he has attended the World Hydrogen Technologies Conference in 2009. Sir he is having the lifetime membership for the IST as well as the Combustion Institute. Also, sir has conducted the conference, which is National Conference on the IC Engine and Combustion in 2017. Before that, he also conducted the FMFP, which is nothing but the Fluid Mechanics and the Fluid Power, which is the international conference, which is arranged every alternative years. So, which was in 2015, sir was the key role for this conference. Along with this, sir is having the different roles in the academic, as well as he is a consultant for the different industries where he plays a very vital role for the researchers. As I go, it is a big list of the CV. Sir,
Yes.
we are very fortunate to have you for this FDP, sir, as a resource person. So we are welcoming you for this, sir.
Yeah. Thanks for detailed introduction. Now the PowerPoint presentation is visible.
Yes, sir. It is visible, sir. Yes, sir.
Yes. Good evening, everyone. Actually, I'm busy with administrative work. I could not modify the PowerPoint presentation. But I would like to share my knowledge, whatever I know related to the IC engine. Maybe some of the things are very useful. My students are there, Mr. Chitragar also. I'm happy to see him on the line. Maybe some of the things already you know, but I want to formalize and I want to share my experience with you. Because nowadays everybody is talking about maybe how to clean fuel or how to reduce the emissions, and yeah, most of them are believing that electric vehicles can reduce the emission in urban areas. But if you see in depth, the electricity is produced from the fossil fuels, because in our country, the electric energy is produced from the coal or fossil fuels like diesel. And because of this, when we burn coal or diesel, carbon dioxide or other emissions will be released. But maybe the emissions won't be produced at urban place where we are using electric vehicle. But if you use renewable energy for electricity, like solar energy or maybe wind energy, then we can say it's a clean fuel, clean technology, or what we can say is carbon-free technology. But at presently, so we have to focus on the existing technology, that is a internal combustion engine. And it is not a today technology, even since from more than 130 or 150 years of experience is there. And still we could not achieve the maximum efficiency. That is when we in undergraduate, we studied the air standard cycles. Everybody will know. Current efficiency will give the maximum efficiency when we burn fuel. But when we take the actual engines, maybe it's compression ignition engine or diesel engine, still there is a way to improve the thermal efficiency or mileage. Okay, so today I'm going to highlight a few things. Maybe the few new technologies are coming in, so that the overall thermal efficiency or the mileage can be increased. That's one thing. Second thing is the alternative fuel for SI engine, so that the not only thermal efficiency increases, even emissions can be reduced. Because nowadays, whether you take any or energy, whether you burn coal or you burn fossil fuel or even utilization of electricity, mainly we are looking for higher thermal efficiency or how to reduce the carbon emissions. So with respect to this, maybe a few slides related to the basic things I prepared for the or graduate students, and then I'll move on to the alternative fuel for hydrogen. What are the advantages and disadvantages with respect to hydrogen fuel? Because the government of India is talking about neat fuel, that is a hydrogen fuel, and even the government funding agencies, they are promoting hydrogen research activities, not only utilization, even production as well as storage. So when we, just a minute. No, slides are visible, no?
Yes, sir.
Yeah. Why when today, if you take a economy of any country, it's mainly depends on the energy, whether it may be availability or utilization. Because even in India, most of the fossil fuels, whether petrol, diesel, sometimes CNG also, we are importing uh, from the maybe Arab countries or Russia or nowadays, even America also, they want to involve in our this one. So what I want to say is the energy is the most factor besides the GDP. And when we take electricity, because we have electricity we are using extensively in all the fields, and the basic source is maybe solid fuel, including coal or fossil liquid fuel or gaseous fuels like CNG or LPG gases. So when we take the fuel, so again, the burning or the combustion is very important factor. How much efficiency will be there? That is an important factor. That's one thing. Second thing is the product. Say after burning fuel, it may be a pure hydrogen, or it may be a combination of carbon and hydrogen. Because when carbon burns with oxygen that is present in the air, so carbon dioxide will be released. But maybe because of some reason, the carbon monoxide will be released, or sometime unburnt hydrocarbon will release. So if combustion is complete, means the carbon dioxide should be there. Again, all this carbon affecting on the environment, how to replace this carbon or how to reduce this carbon, that is we have to look for the one is the better combustion, so that maximum efficiency will be there, and second one is we have to replace the fuel. That's one thing. And with respect to hydrocarbon, already we know when we take petrol, maybe generally we work with a stoichiometric condition. Maybe diesel, we may work with a lean mixture or slightly rich mixture. But again, when we use a hydrocarbon, the carbon dioxide will be present, and along with the nitrogen or nitric oxide will be produced. So we are, when a lot of technologies are developed, and anyway, I'm going to highlight a few technology, including SCR technology. So, and most of them already, you know how ice engine work. It is similar to the cannon used in the war field. So, when iron ball is placed in front of the uh, igniter, okay. So, if you give some spark, the uh, powder, whatever gunpowder is there, it will get ignited, and produces high pressure waves, and strikes the ball, and it moves very fast. The same concept used in the internal combustion engine. So when we supply petrol or diesel or liquid fuel or gaseous fuel inside the cylinder with a required quantity of oxygen or required quantity of air, the combustion happens, and it produces high pressure waves on the piston. So the piston will move, and there is a mechanism for converting motion into rotary motion, oscillatory motion into rotary motion. So because that, how ICE engine works. Okay. So same concept used in SI engine as well as a diesel engine. So with respect to PV diagram, just I'll take 5 to 10 minutes. So with respect to this one, we studied air standard cycle, failure cycle, as well as actual cycle. We have seen the air standard cycle will give the maximum efficiency, but we made a lot of assumptions, including only the pure gas will be there, air, and the property won't change, heat losses will be less, and etc. and etc. But when we take the actual engine, so a lot of heat losses will be there. We are considering the property of the fuel along with the air, and the combustion is not completed fully. And not only that, in fuel air cycle, we are considering instantaneous heat addition, but in actual engine, it is a progressive combustion. Because of that, there will be heat loss, there will be incomplete combustion, there will be dissociation also will be there. So these are the some drawbacks. So how to improve this drawback so that it engine can give the best efficiency that for a given fuel or this one. So this a PV diagram with respect to the different conditions. Okay, and nowadays we are focusing on turbocharger engine so that for a given volume, the power can be increased. That is, we can put more charge so that more heat will be generated and more output power will be there. So today we are looking for turbocharged ICE engines, including SI or CI engines. This I'll skip because assumptions made with respect to that. Assumptions. So even today, just I'm highlighting few advanced technologies used in new engines. So earlier we know the inlet manifold, it is coming with only throttle body and maybe with air filter. But nowadays the throttle body is removed and electronic control units are placed based on the piston position or based on the load, the fuel and air will be supplied. And even the mechanical valves are replacing with solenoid valves. The required quantity of air will be supplied to the solenoid valves so that the mechanical maybe crank mechanism can be removed so that the overall efficiency can be improved. There's a few technology used in high-end cars. Okay, and even the redesigning of the manifold so that the pressure drop can be reduced and throttle body is also removed. Okay, these are the few things. Instead of natural aspiration, we go for forced aspiration, the turbocharging or supercharging, and sometimes we can inject the steam or some water content so that the combustion temperature can be reduced or NOx can be reduced, and addition of NOS system or oxygen addition system so that the better combustion can be achieved. Now, what I want to say is a few things, new technologies added here so that better combustion, better performance. Next, with respect to compression, I think you might have heard maybe even deactivation cylinders. For example, 4 cylinders are there. When we are standing in the traffic junction or whenever we don't require more power, maybe when decelerating in downhill. So that time we don't require more power. Then we can cut off the charge to the 1 or 2 cylinders so that 1 or 2 cylinders can be run. So that is minimum consumption of fuel, and by this we can improve the more thermal efficiency. And second, with respect to the spark ignition engine, the gasoline direct injection is also coming in, and even diesel engine, CID engines are there. The injection pressure is increasing day by day. Maybe a lot of research is happening. So earlier, maybe if our mechanical injection pressure was around 200 bar, and now it is increased to more 10 times more. That is 2000 bar. So what I want to say is the new technologies included in every stroke of the power stroke engine. Okay. And the ignition system also, a lot of changes happened. So people are working on laser ignition system just to improve the combustion efficiency. Because when we take the battery operated ignition system or mechanically timed ignition system, we have seen sometimes misfiring, or the sufficient energy was not supplied because of maybe, I mean, when fuel ratio changes, that is maybe sometime rich or sometime lean, so misfire was occurred. But when we move to the digital electronic ignition system or laser ignition system, but laser ignition system still at laboratory condition, not at onto vehicle, but digital electronic system is already adopted in most of the vehicles, and it gives the better combustion. It initiate the combustion in right way and right quantity. In exhaust stroke and exhaust manifold, already highlighted, the turbocharger or superchargers are used, and sometimes the exhaust gas recirculation is done, because when we burn petrol or diesel, hydrocarbon, and when you supply air, so nearly 79% nitrogen will be present. When it burns, so nitrogen oxide will be produced, that is nitric oxide, that is NO or NO2 or NO3 will be produced. So to reduce that one, because nitric oxide is increases with respect to the combustion temperature. If combustion temperature is more, then NOx emission also will be more. So how to reduce the combustion temperature? Just one is, maybe we have to work with a linear mixture. So that is, we have to supply less quantity of fuel. If you supply less quantity, then less power. So it is a drawback. So, but the another way is to reduce the, by supplying exhaust gas recirculation. That is, whatever exhaust gas is going, maybe 5 to 20% exhaust gas can be recirculated. By doing this, we can reduce the combustion temperature, and when reduces, then NOx will also be reduced. The alternative NOx or other emissions reduction is catalytic converter, so that whatever exhaust is, harmful gas is going outside, we can capture through the catalytic converter. Okay, and we can use a intercharger in a turbocharger as well as supercharger, so that the overall efficiency can be improved. Okay, so the exhaust gas can be, the heat or energy present in the exhaust gas, we can reutilize, or the overall efficiency of the engine can be improved by adopting the preheater or preheating the air or fuel. Okay, that is advantage. Or sometime we can, by using the Seebeck effect, that is by thermocouple or some, we can generate the energy, but it is a very small quantity. A lot of research is happening, and whatever electric energy is produced from the Seebeck effect, that can be fed to the battery for recharging. But it's not adopted every vehicle. There's one, but a lot of research is happening how to utilize the waste heat, because instead of leaving to the atmosphere, how to use the heat in the present in the exhaust gas. A lot of research is happening related to this. Okay. So what I want to say is, whether you take a petrol engine or a diesel engine, each stroke there is some technology, so that we can improve the overall efficiency of the engine, and we can reduce the outgoing emissions. This I'll skip. Okay. So now I'll come back to alternative fuels. So why alternative fuel is necessary? Because the fossil fuels are available plenty. in most of the country in Arab or Russia or America. The fossil fuels are available, including gaseous fuel like CNG or LPG gas. But we know, if you see the slide, the population is increasing day by day. Okay, maybe after now only 6 billion people are there, more than 6 billion, and maybe after 15 to 16 years, it may reach 9 billion. And people are moving from village to a rural area to the urban area, where all the facilities are there, including the transportation or electricity consumption. So when you take a house in urban, so you need electricity for home appliances as well as for transportation, for everything. So energy is required. So energy is an important factor in coming days. So if you see the graph, the China, India, and other Asia Pacific countries having a 75% population, because India maybe it already crossed 150 crores. China is also next to India, so around 300 plus population, crores population in world. So, and other countries like America and European countries, including Africa, the rest people are located. And the population is generated everywhere. And you can see heavy duty transportation with respect to the region, even because of population, maybe transportation also, or energy consumption is also increases day by day. Okay. You can see this how it goes. Here the population is very less, but energy consumption is happening at present equal to the Asian countries. Energy demand by sector. So maybe the electric, with respect to energy consumption and electricity or industry or transportation, residential or commercial. So you can see how energy is growing every day. So by considering this, the government of India is bringing a smart city concept so that the transportation can be reduced, or the consumption of the energy in the residential or commercial can be reduced, even industry also. Because, for example, the smart cities, the offices are reallocated or rearranged properly, so that you don't, person don't have to visit the office by online. That is by using internet, we can submit our application, we can do other activities. That's the one thing. And second thing is the electricity produced at far away, that is maybe power station is located 500 kilometer or 1000 kilometer, and when electricity is supplied from there, a lot of energy will be lost. That is, when you produce 2 units of energy, only 1 unit energy will be reached to the urban because of transportation. Yeah, when transmit energy from powerhouse to the household, or urban area, so transmission losses will be there. So to avoid this one, maybe the solar energies are installed in house rooftop, so that the energy can be produced and utilized without any hassle. So the government of India is bringing the renewable technologies, so that they can less dependency on the carbon coal or diesel and etc. So that is a smart city concept. And with respect to transportation, energy demand by sector, so you can see light duty, heavy duty, and aviation and so on. So when maybe personal vehicle or the heavy duty transportation, the goods transportation falls under this. And but in India, so we are depending on all, including train or bus and personal vehicle. So this is with respect to the different countries or region. You can observe North America, Europe, and Asian specific thing. And when population increases, so the energy demand also. So this is with respect to this different types of vehicles. And nowadays, the automobile manufacturers are they're bringing electric vehicle or plug-in hybrid. The both we can operate the internal combustion engine as well as electric vehicles, so that the overall efficiency can be improved instead of using a pure pure fuel. Okay. So you can see 70% of the diesel account for some growth of transportation, because the public transportation is mainly depending on the diesel, including the goods transportation. And nowadays they are bringing electric vehicle, but again, as I said, when you are running for long distance, sometimes there is a drawback, and even charging it takes long time, as well as emissions are present. Okay. So these are the different fuels used at presently. Okay, a small quantity, because when you take biodiesel or ethanol, because in India now we started using maybe 5 to 10%, 20% ethanol now, so that petrol can be reduced. It's the same information. And emission, so it is increasing day by day. Carbon dioxide. So I think most of them you are knowing. In 2015, there is a world leaders met was there. That is a Paris Agreement. So in the agreement, that is how to reduce the carbon emission, or how to replace this fossil fuel with other fuels like maybe renewable energy or the hydrogen, which is produced from pure renewable energy, not from methane or electricity, the electrolysis method. So again, the same information depending upon the number of vehicles used in the region. So you can see based on the population, more emissions will produce in this one, and other countries are produced less. Okay. This is similar information. Just you can, I'll share this PPT. You can refer. And this is with respect to the how energy consumption, because the energy consumption is a very important thing in India, and Bureau of Energy is energy efficiency is giving a lot of policies with respect to commercial, or with respect to industry, or with respect to any home appliances. This one, so they are bringing policies so that minimum energy can be saved by introducing a new technology. So this is with respect to how each individual sector, the energy consumption percentage. And maybe in future you can observe, not future, within 5 to 10 years the hydrogen technology will come in. But again, the production and storage is also a major research area nowadays. A lot of universities and companies, they are working on production, storage, as well as utilization of hydrogen. Because if you see the hydrogen, there is no carbon content. So after combustion, only pure water will be released. So with respect to production, storage, and utilization, a lot of work is happening. Now, if I consider hydrogen as a fuel, earlier, history is there why it was not considered and why it is considered nowadays. Because when you see the history, generally hydrogen is used for bombing purpose, okay, in warfare. And nowadays, we know how to control the combustion with a safety, okay, because nowadays safety is a very important thing, and we have sensors. We can control the combustion of hydrogen combustion, and because of that, a lot of research is happening related to the hydrogen combustion. And when you see the physical and chemical properties, you can observe here. So hydrogen is the most abundant element in the Earth or universe, but only thing is it is not available pure. Even when you take a, crude petroleum one, so it consists of hydrocarbon, but in different level. Viscosity is different, caloric value is different. So after processing, so petrol or diesel or other kerosene, etc., will be segregated and used in the uh, devices. So that is the one drawback. Atom, this one, uh, hydrogen is found in different form, and energy content per unit volume is very less. That is one more this one. But there is a way to improve the energy content. I'll come back to you. And disadvantages just listed here. Hydrogen is not naturally occurring fuel. Again, when you take CNG or coal, it is naturally available. We can store it and we can supply. But hydrogen, it is combined with other elements, maybe carbon. Okay, so we have to segregate or separate the carbon and the hydrogen. Okay, that's one thing. When we use, presently in India, generally what we do for production of hydrogen, we use electricity. When electricity is used, then it is expensive because the electricity again come from coal or other fuel, and that fuel, losses will be there. So hydrogen per unit cost will be more compared to coal or CNG gas or petrol or diesel. Okay. Similar way, hydrogen transport storage is also expensive and difficult because, as I said, uh, generally used for explosive purpose because it requires minimum ignition energy, and once it gets minimum ignition energy, it explodes. Okay, that's one. Okay, why this or fuel is considered for today's condition? We are generally, I can say it's a renewable energy. If you see this graph, you will understand, yes, hydrogen is a renewable energy because when you take a hydrogen, maybe we can produce from renewable, maybe some coal or CNG gas, there is a methane gas, or it may be electrolysis method. There is a water can, hydrogen can be produced from water. After producing hydrogen, so it can be stored and transported to the utilization area. And the remaining oxygen, maybe we can store or we can leave it to the atmosphere. So when we are using as in internal combustion engine, so again we require oxygen. Maybe pure air is taken, oxygen or pure air is taken. Combustion happens. After combustion, you can observe the product will be water. Okay, so it is nothing but not a harmful product. So afterwards, maybe again recirculate, use the electrolysis method. You can produce the H2 and O2, and again. So it is a renewable energy. Okay. So again, when you start using a hydrogen, so how to produce? That is the one question, because as I said earlier, electrolysis method, the simple chemical process, what we understand during school days. So use electricity so that we can produce the, or we can split H2O into H2 plus O2. So that is the one nice one. But only thing is we have to use the electrical energy. So after using electrical energy, then we have to store oxygen plus hydrogen, and then we have to transport. That is the one major thing. So at presently, the technology available, there is a production of hydrogen. There are many technologies. In that, 5 technologies are listed here. One is a steam methane reforming method, and second one is electrolysis of water, and the third one is renewable energy sources, biomass. So it has got, first 3 or first all 5, if you consider, it has got advantages and disadvantages. The last 2, that is a direct thermal decomposition of water and nuclear energy, this all laboratory level, but it's not come to the at the common man, because direct thermal decomposition water, that is, water can be split into hydrogen and oxygen with a temperature of around 2500 degrees centigrade. So if you want to maintain that temperature, it's very difficult. Again, a lot of energy is required. So that is a laboratory level. A lot of research is happening. So last one, nuclear energy. Already you know, even though the nuclear technology is available in India as well as worldwide, but a lot of restrictions are there because the developed countries putting a restriction on India not to use nuclear energy for power production, because they think that we are using for the war purpose. But the first three methods is a very simple thing, and it can already used in many organization for batch production or mass production. The first method, steam methane reforming method, that is whatever CNG gas, because when you take the CNG gas, around 99% methane will be there, CH4. So when methane burns with oxygen, so carbon dioxide and hydrogen will be produced. But how to reduce carbon dioxide in urban area? So you convert methane into hydrogen. So like this, and carbon dioxide we can release there in remote area, and we can reduce the carbon dioxide in urban. But again, the overall emission added to the atmosphere remains same. Whether you burn in urban area or in remote area, this much carbon dioxide will be added to the atmosphere. But only thing is, in urban area, at that condition, it will be less. But how to convert methane to hydrogen? You can observe the reaction temperature should be around 700 to 1000 degrees centigrade, and catalyst we require, that is a nickel or chromium, nickel or aluminum oxide or cobalt catalysts are used for producing methane to hydrogen. Okay, the simple diagram is this. So we are supplying steam and hydrocarbon, it is methane. So the reaction happens, the temperature and chemistry will be there, and low temperature, high temperature, and etc. So finally, the hydrogen is produced and is taken out. Because when after splitting, carbon dioxide and the hydrogen will be there, we have to segregate. Then pure hydrogen is taken and stored in the cylinder. The advantage is hydrogen, with this method, that is a steam methane reforming method, we can do it on site. Okay, on site production, because wherever CNG gas is available, we can convert CNG to hydrogen and we can supply through cylinder or by pipeline. That's the one advantage. Second one is cost efficient, because compared to other electrolysis method, because CNG gas is available at lesser cost compared to the hydrogen produced from the coal. And the disadvantage may be finite resources or rising natural gases, fluctuation happening plus or minus. And this is the technology we are familiar from school days. So, using electricity, water can be splitted into hydrogen and oxygen. You can observe here, water is taken and current is supplied to the anode and cathode, so that reaction happens, sun is created. Okay, so only thing is the cost of electricity is added here. No carbon dioxide, because we are supplying water, pure water, H2, and no question of carbon dioxide, and distributed hydrogen generation. That is, wherever you require, when energy is required, hydrogen is required, so we can install this system and we can produce the hydrogen. But only thing is it is expensive because electricity. One more thing I deleted. So here, renewable energy, generally pyrolysis method is added here. So we can use biomass or any biomass can be used, wood or gobar and etc. We can produce hydrogen. So when the source is lesser cost, then hydrogen production is also less. But only thing is disadvantage is when we burn biomass, generally uh, carbon dioxide also will be there, more carbon dioxide, that is the impure hydrogen will come. So again, for segregation, we have to invest money. That is a disadvantage of renewable energy. Okay. So at presently worldwide, you can see hydrogen is produced by steam methane reforming method around 48%, and oil consumes coal and electrolysis. Even from coal, by using a pyrolysis method, we can produce hydrogen. But again, it's a laboratory level. But for mass production, at presently, they're using a steam methane reforming method. So after producing hydrogen, the next question is hydrogen storage, because when you see the property of the fuel, it is a very light fuel, gas, 0.08 kg per meter cube. When you take air, maybe 1 kg per meter cube. So when you take the liquid fuel, maybe 800 or 900 or 1000, 850 or 900 kg per meter cube. So water is 1000 kg per meter cube. So when you compare to liquid fuel like petrol or diesel, which is a very, very light fuel. So if you take at atmospheric temperature, we cannot store even 100 gram. So we have to go for high compression. So generally, maybe 200 bar or 300 bar. When we use 200 or 300 bar, the body of the cylinder should be very strong because it should withstand with the high pressure. And next method is liquid hydrogen. So thing is liquid means at maybe minus 160 or minus 180 degree, mean we have to maintain that is a cryogenic condition. Then only liquid liquid form or phase we can maintain. Otherwise, it will evaporate and it will be in gaseous form. Metal hybrid form. So that is again simplest technology and less investment. So generally, only thing is the storage will be very less, and the efficiency of this metal hybrid method is also very less. It's not used extensively. This is how compressed cylinders are used. I think you might have seen in welding shops. Generally, the hydrogen gas used for welding purpose, and maybe cylinder pressure varies from maybe 150 bar to 200 bar, and maybe half kg can be stored at high pressure. But half kg, when you adopt in a vehicle, so we cannot run for long distance. So instead of that, we have to go higher. Go for higher pressure with a reinforced cylinders, that is a carbon fiber reinforced shell, and even type A and type B cylinders, we can go for 700 bar hydrogen storage. Metal hybrid. So lithium hydroxide or some materials are used for storing the, or generally this metal will absorb the hydrogen, and when we heat it at 120 degrees centigrade, so it releases hydrogen, and that the gas can be connected to the IC engine manifold. Okay. So maybe some eminent persons have told some sites, but right now it's correct. But including even India also, our Dr. Abdul Kalam ji was also told, why can't we initiate the research work related to the hydrogen? And maybe his thoughts have come true now. A lot of research is happening related to the hydrogen thing. So when we take the hydrogen, today I'm focusing on internal combustion engine. And at the laboratory level, a lot of research is happening related to the fuel cell, and fuel will be hydrogen gas. So when we compare between ICE engine and fuel cell, you can see the advantages and disadvantages. Okay, and there's a green are all similar thing. And when we look for the other things, overall efficiency is less in ICE engine because the combustion happens, so heat losses will be there compared to the fuel cell. More noisy because of combustion, silent, just like a battery, and maintenance. Nice engine moving parts will be there, a lot of vibration and sound. Whereas fuel cell, as I said, is like similar to the battery, no noise and moving parts. But only thing is disadvantages you can see longer or shorter charging, and here less and size. Weight is also more in the fuel cell compared to the ICE engine, and expensive materials are used in fuel cells. No expensive because cast iron or aluminum alloys are used in ICE engine, and well-developed technology. There is ICE engine 150 or years of experience, but this fuel cell again, few laboratories or few manufacturers are working on this. See, after finding hydrogen or any fuel, the properties are very important thing. So I listed a few properties comparing with gasoline. You can observe hydrogen compared with gasoline because we are familiar with gasoline, that is a petrol. So we know how it burns, what is the emissions will produce, and what are the stand properties at what temperature or operating condition. So when we compare CNG and hydrogen, you can see one is flammability limit. So wide here 0.724, here 0.12714. That is even very rich mixture or very lean mixture we can operate. That is the advantage of hydrogen. And burning velocity, because of this, maybe we can change the power output. And because of linear burning velocity, that is once the combustion is initiated, how fast the flame is moving within the combustion chamber. When you compare these two, that is a gasoline or CNG with hydrogen, hydrogen is having a very good flame or burning velocity. Because of this, maybe we will get the better thermal efficiency because burning velocity is fast. Whatever fuel we are supplying will burn fast. Okay, complete. Octane number you can observe maybe 93 or presently in market, but with respect to hydrogen is 120, and already we know when octane number is good, we can go for higher thermal efficiency, and thermal efficiency can be improved a lot. So that is the advantage of hydrogen. But disadvantage, as I said, the density of the hydrogen is 0.08 compared to air is 10% less, 10 times less. So it displaces the pure air. So the overall power will be less because it occupies hydrogen and less air is coming, less fuel is entered, and the power output is also will be less. I mean, from the experimental point of view or from the literature or my experience, we have found that nearly 20 to 30%, 15 to 20% power will be less, even when we operate with the 0.8 or 0.9. But when we move to the maybe high pressure, turbochargers or direct injection, so we can improve the power output. That is by direct injection, but I'll come back to it later. And the next thing is the minimum ignition energy. Compared to petrol, it requires very small amount of energy, that is in terms of millijoules. So even if it heat is present in the valves or spark plug or including lubricant oil, the combustion is initiated. So the pre-ignition problem will come. That is one more disadvantage. But it can be minimized or it can be nullified by adopting the new technology. Okay, that's the one more thing. And the another disadvantage is quenching distance. You can observe the flame is moving nearer to the wall. So already we know how ICE engine works. So generally the lubricant oil will be present on the inner surface of the cylinder. When flame is reaching lubricant oil, then lubricant oil also will start burning. for us, it should not burn. Otherwise, the addition of lubricant oil or the cost of lubricant oil also will increases. Okay, and one more advantage with respect to the per unit mass you can observe. So megajoules per kg. So 3 times higher than the petrol. That is the one advantage of this. Okay. So the first disadvantage when we are working with hydrogen. So I don't know, uh, uh, some are already experienced. So when we use hydrogen, pre-ignition problem or flashback or rate of pressure rise will be experiencing. So we want rate of pressure rise. That is the peak pressure should come near to the top dead center, but it should burn in a controlled manner. Otherwise, the peak pressure is coming before the top dead center, then wastage of energy and loss of energy will be there. Pre-ignition or backfiring, that is before power stroke, if the fuel is burned, then again it affect on the overall efficiency. So after considering the uh, disadvantage, but using the new technology, including electronic control system or solenoid valve operated injectors and etc. So hydrogen can be used in both SI and CA engine. So maybe we can use pure engine, pure fuel in a spark ignition engine or along with gasoline or CNG. Nowadays, you might have seen CNG plus hydrogen. That is generally called high-ten fuel, HY high-ten. That is hydrogen plus methane. So maybe 15 to 20% hydrogen will be added in CNG gas so that carbon content can be reduced, the burning velocity can be increased, or the overall efficiency can be improved. That is the advantage of high-ten fuel. And diesel, maybe pilot fuel, diesel, and the rest as a substitute fuel as a hydrogen can be used, but preferably used in spark ignition engine because previously we have seen the properties are matching with gasoline and CNG gas. So maybe these are all outdated, okay? Because nowadays we are focusing on injection system, maybe continuous injection or terminal also. But again, this also outdated. If we have a proper sensors and electronic control in it, so we can go for inlet manifold injection, that is a timer manifold injection or port fuel injection. But as I said, because of new technology, in cylinder injection we can use. That is direct injection with a low pressure or high pressure injection. So advantages in carburation, again, knocking or the overall efficiency will be reduced because we operate with a very lean mixture. Even continuous injection, because the injectors are placed in the manifold. So sometime because of pre-ignition, the combustion takes place during section stroke and the knocking will come or backfiring will come. Okay, the cracker sound will come. But maybe with a controlled manner, timed injection or timed manifold injection using electronic control management we can use. Okay, so this in cylinder again, maybe even gasoline direct injection technology is available. We cannot use same technology for hydrogen because hydrogen density is very less. So when we use injector for this, there will be leakage, there will be backfiring. So a lot of disadvantages are there. But maybe a lot of research is happening related to the material. Maybe within 2-3 years, the new technology will come. Once the in-cylinder technology comes, maybe we can switch over to the hydrogen directly. International status, a lot of research is happening. Most of the Indian automaker also, they are working on this, including Tata Motors, Mahindra, and other companies. They are working on hydrogen utilization, and even government is promoting that. Okay, these are a few cars are available, and this was my vehicle. There is I I worked on this area vehicle. So previous vehicle developed at IIT Delhi along with Mahindra, and maybe at presently it is available in IIT Delhi. So, and as a mechanical engineer, as a IC engine man, when we use hydrogen, how the performance will increase. Okay, so when we do laboratory testing, so you can observe the power output. So here, even though when we work with around 0.6 or 7 air fuel ratio, so it is in, I mean, sorry, equivalence ratio, the power output will be less compared to the petrol. So you can observe it is coming around this. So it will be 20 to 30% less because of less density. When we add even at one equivalence ratio, so the power output will be very less. Thermal efficiency is very good. So in the property table, we have observed because of burning velocity, the thermal efficiency increases, and compared to the petrol, the 0.34 and 2.1. So this is inversely proportional to the thermal efficiency. So the energy consumption for producing kilowatt hour or so 1 kilowatt hour, you can observe less energy consumption compared to the petrol. So that is the advantage of hydrogen. So volumetric efficiency in power output, you have seen the brake power versus speed. So brake power will be less. So because of volumetric efficiency, as I said, the density is very less, and volumetric efficiency of the engine also reduces compared to the petrol. Because when you take petrol, nearly 98% or 97% are filled with pure air, and 2 to 3% filled with petrol. Whereas here, around 30% filled with hydrogen, remaining 70% filled with air. Okay. So with respect to air and this one, the power output will be less. Okay. But how to improve? We can by adopting the turbocharger. Okay. That is the advantage. One more disadvantage we can see when we operate with a very low mixture. I mean, less than 1, you can see, I mean, how the NOx is increasing. And that too, if you take less than maybe 6 or 7 or 8, you can observe it will be very less. But when we operate with more than 1 equivalence ratio, because of higher thermal, I mean, combustion temperature, the NOx emission will be high, and we can control by operating very low equivalence ratio, or we have to adopt some retrofitting method so that NOx can be reduced, just to compromise between power output and emission. So now, after a presentation, the production already I told for large quantities we are using a steam methane reforming method, and for pure electrolysis method. And so this is with respect to production, and with respect to the some utilization. Hydrogen can be used as an alternative fuel in SI engine with a minor modification. That is, we can avoid back normal combustion, and we can use mixture formation and improve power output and reduce the emission. Okay. So this one. This completes my presentation. Now open for discussion. If you have any specific queries with respect to IC engine, please.
Dear participants, if you have any queries, you can have the questions to this, sir.
No, continuously I spoke, so I think many have got bored. So please, if you have any specific questions, please.
If anyone having the question, please you can ask to sir. Sir, I think all are understood. You have explained the things very detailedly about the IC engine, as well as how the renewable energy we can use it for the IC engine, like a hydrogen. And also, sir, you have given the glance on the exhaust systems, how we can use it, as well as how we can utilize these things to minimize the pollution. Also, sir has explained very nicely about the different turbochargers and the alternative fuels, mainly the hydrogen. Hydrogen, the main advantages, disadvantages, and how the production as well as the storage and the proper, like the relevant properties along with the gasoline and the CNG. And what is the current scenario in India as well as the uh, world? So where all the world is looking for the clean energy. Sir, it was really a nice session, sir. You have given the full glance on the IC engine. Even like BTech students can understand the whole detail of the IC engine, sir. So it was really nice, sir.
No,
So,
somebody raised a question related to hydrogen. I mean, how to produce best way. Combination of solar energy. Yes, electrolysis method is the best way. Or in this one, steam methane reforming method, we have to maintain 700 to 1000 degrees centigrade. If you solar energy, again, maybe the best way is to convert into electric energy and use in electrolysis method. The advantage is we'll get a pure hydrogen. That is using solar energy. Otherwise, we can go for steam methane, including pyrolysis. Yes.
participant,
Hello.
No,
Hello.
somebody, wait. Somebody has raised, Parisharam, I'll come back. Somebody raised
Okay, sir.
hydrogen production emit carbon dioxide, then how we can say it as a green energy? Yes. See, it is not a green energy if you produce from coal or because already I mentioned if you use solar energy or wind energy for producing hydrogen, then we can say it's a need. Otherwise, we cannot say it's a green fuel. Next. Yes.
Hello.
Yes.
Am I audible, sir? Yeah, good
Yes,
evening,
sir.
sir.
Yeah, please.
Yeah, good evening, sir. Very happy to see you on this platform, sir, online platform. And
Thank
good
you.
evening, all participants also. Just, sir, I wanted to know, so what is the futuristic points for the use of this hydrogen in particularly vehicular operations?
See, when one slide I said fuel cell. Maybe, presently the fuel cells are not came to market because of material or because of maybe, it is under laboratory condition. Maybe the fuel cell with the hydrogen fuel, it will come. But presently, the hydrogen fueled IC engine vehicles will come because the government of India is promoting. They are putting a lot of effort just to maintaining the agreement. That is, as I said, 2015 they made agreement with all the countries for reduction of carbon dioxide. They are working on this.
Okay. So in that case, so we can modify the existing engines to operate on hydrogen.
Yes, even manufacturer also they are working on that. Exclusive or biofuel type engines will be released, just like a LPG with petrol or CNG with
Yes.
petrol. Similar kind will come.
Yeah. Thank you, sir.
Because,
Thank you, sir.
because nowadays electronic control management is used extensively in vehicle,
Right, sir.
including sensors, actuators. There are a lot of new technologies are coming in.
Yeah.
Yes.
Thank you, sir. Thank you.
Uh, sir, on behalf of organizing committee and from the Nutan Maharashtra Institute of Engineering and Technology, so I would like to thank Dr. Kumar GN sir. In spite of busy schedule, sir agreed for our invitation because currently sir is heading as a in-charge registrar in the NIT Surathkal. So he'll be having a lot of pressures as well as the work. So, sir, really, we are.
Okay, no, no.
Thank you, sir.
So I thank organizers, including Madhu, for giving opportunity. Long back, I accepted. I could not modify the slides, but I hope I have given I shared my experience with you people. Thank you, thank you, Honorable.
Thank you, sir. Thank you very much, sir. Good night.
Good.
Thank
you, Honorable.
Thank you, sir. Dear participants, we'll have a 15 minutes break. So we'll reconnect at 7:25 sharply, so that our next session chair will be available at 7:30. So I request all of you, please rejoin at 7:25 sharply. Thank you.
Okay, sir.
And also please fill the feedback form which is shared in the WhatsApp as well as this chat box. Sir will rejoin at 7:25, sir.
Sir, we will keep on this link. So I think no need to log out. We will start directly at
Yes, sir, it
7.
will be open. Just they can come
Yes.
later. They can come and.
So request to all the participants. Link will be open throughout the time. So no need to log out. So we will meet at 7:25. Meanwhile, I will share the link in the chat box and the WhatsApp group for the feedback. So I request to all the participants, please fill the feedbacks. Your feedback is important for getting the certificates and attending the test. For last yesterday session, I got near about 150 feedback. So we are having total 206 participants. So I request to all the participants, give your valuable feedback. Then and then it is easy for us for the certification process.
Thank you, sir.
Biradar sir, can we start?
Just a minute, sir. Dr. Praveen, whether joined or not.
Okay.
Yes, sir. I think Dr. Praveen has joined, sir. Praveen, sir.
Hello, is it I'm audible?
Yes, sir, you are audible.
Yeah, okay, fine.
Yes, sir. Once again, I'm welcoming all the participants for the second day's second session, which is fourth session of this ATAL FDP. Now, I request Dr. Satish More, sir, co-coordinator of this FDP. Please, sir, introduce Dr. Praveen Tia, sir.
Yes, sir. Thank you, Dr. Biradar sir, for giving me an opportunity to introduce our today's speaker, Dr. Praveen sir. So, good evening, Praveen sir.
Good evening. Good evening to everyone.
Yes. So, good evening to all, and welcome of our fourth session of this online 6 days ATAL FDP. So, we are privileged to welcome Dr. Praveen sir, an accomplished researcher, academician, and industry expert with extensive international experience in advanced material, mechanical design, and aerospace engineering. Dr. Praveen recently completed his postdoctoral research at the Department of Material Science, Sao Paulo University, Brazil, where he worked on the cutting-edge research in the biodegradable orthopedic implants. His work focused on the material degradation mechanism, magnesium-based biological material, and its processing and the surface enhancement technique. He holds a PhD in the mechanical engineering from NITK Surathkal and ME in the machine design from University of Visvesvaraya College of Engineering, Bangalore, and the B Mechanical Engineering from VTU. Dr. Praveen has a work as an ad hoc faculty at NITK Surathkal, contributing to the teaching laboratory development and online pedagogical development during the pandemic. His industrial experience is equally notable. He has served as a senior analysis engineer with Airbus in Germany and India, supporting the major aerospace program including A320, A330, A380, and A400M. He also holds rich experience from the National Aerospace Laboratory, where he worked on the aerostatics analysis, micro air vehicle development, composite structure, compatible aerofiles, and the impact simulation using the advanced FEM model tools. Currently, Dr. Praveen serves as a senior consultant at Harvester Desk, where he lead R&D project including automation, advanced manufacturing, renewable energy system, CNC machine development, and biodiesel technology. His expertise span finite element analysis, lightweight materials, laser shock processing, structural optimization, and the biomedical materials and industrial automation, supported by the mastery in the tools like Nastran, Abacus, LS-DYNA, Hypermesh, and CATIA. Dr. Praveen has published several research papers, hold the awarded patent, and has received recognition, including the Best Poster Award at IIC Bangalore and the Presentation Award at the Alter Engineering College Conference, Bangalore. His diverse experience across the academy, industry, and international research make him an exceptional resource for his faculty for this faculty development program. Let us warmly welcome Dr. Praveen sir. So welcome again, Dr. Praveen sir. Now I hand over the session to you. So welcome, sir.
Thank you.
Sir, we have the time 7:30 to 9 p.m., sir. 1.5
Okay. Copied. Okay, I will try to make that allotted time useful.
Yes, sir. Thank you, sir.
Okay, I think my screen is visible right now, right?
Yes, sir.
Yes,
Okay.
sir.
So first of all, I thank the organizers and the convener of the this workshop for giving the opportunity for me to express my terms in terms of carbon capture and mitigation of pollution through industry. So basically, I belongs to mechanical engineering. So mechanical engineering, basically, I work with manufacturing units and all. So let's go through just in basic building blocks how exactly this carbon capture is important and with respect to manufacturing industries. So what is manufacturing industry? Manufacturing industry, it's almost like 100 years back, it started around like 1840, something like that. So before that, yes, around 150 years. So very basically, the raw material should be converted into process goods. For example, this the picture. What you're seeing is a crude oil process unit. Okay, so the crude oil is extracted from the earth base and it is processed to get the different types of fuels like petrol, kerosene, diesel, LPG, and many things. So raw material is processed to get the finished goods in different forms. Okay, so this is what exactly manufacturing industries is concerned. So just in case of example, if you take how the manufacturing industry works with the automotive industry, so the main input, what you're seeing is a material. Okay, so we have to observe this one. Material we are going to invest, energy and water. So these are the main resources we are going to use for any production unit. So what we are going to do, materials will be converted into fabrication part. We will check the properties and what is the cost. So these are the things comes in the basic building block of the design. Then we'll go for the manufacturing, design and manufacturing, joining technology, different kind of things. So this is the assembly line. So once fabrication is done, design part is done, manufacturing of each component is done, we'll go for the assembly line, testing, okay, envisaged design. Okay, so then after that we will go for the durability, maintenance, corrosion, then finally dismantling, okay, sorting and recycling. Okay, so what this picture try to explain is one side you are able to see the green part, another side you can see the orange part. Okay, so this is the basic fundamental blocks which is invested for the automotive industry. Okay, so these are the different procedure we have done, okay, for the life cycle. Finally dismantling, recycling is done, and this is the output we are going to get. Okay, so the input are materials, energy and water, the output is waterborne, emissions and solids. Okay, so this is what happens in the manufacturing industry or any the current industries going on. It may be similar to the automotive, similar to aerospace, similar to defense. Okay, lot of things. Okay, just one more example I will try to give in civil industry. What is going to happen? The main civil industry is construction of buildings, right? So main building blocks for the construction is aggregates, the bricks, sand, and cement. So basically, so these are the process. Just they are trying to fragment the big rock into aggregates. So the manufacturing of bricks include the clay. They're going to make a killing oven. Okay, so in that they are going to bake the clay and you get the bricks. Okay, sand and cement. So everywhere you are also you are able to see. Sorry, we are able to see the formation of aggregate requires energy, right? They want to operate through the machines. The red bricks requires a fire, a source of heat and the energy for the manufacturing. So sand probably we are going to get, but we need a transport from one place to another place. Cement, how the cement is going to manufacture? So there is a raw material dumped to the truck. Okay, so there is a crusher. It will grind the cores into smaller one. Secondary crusher, we are going to proportional equipment. We are going to add a proper proportion to make a proper cement. The grinding mill make it very soft powder. Then preheater tower. Okay, then we are going to clean. Okay, here high temperature is processed. The raw material will be converted into the cement product. Okay, by using a proper heating equipment. Okay, so this is going to heat recycle. We are going to eject the heat again for the preheating purpose. Okay, we will add a gypsum also here. So finally, we are going to get the cement for the constructions. So basically, what we are able to see here, we need energy for the transporting the raw materials. To operate all these kind of machines, we need energy. We need energy for the firing purpose. Okay, again we need energy for the transportation, right? So everywhere we need energy. So in the previous year also we need lot of energy. Here also we need lot of energy. Similarly, if you go to any industry, like okay, uh, automotive industry, chemicals, food and beverage, textile, plastic, metal manufacturing, consumer goods, energy, aerospace and defense, electronics, industrial machinery, pharmaceuticals, paper printing, furniture, building material construction, medical equipments. Anywhere if you go, the energy is most common factor, right? How we are going to get the energy, we will discuss in the further slides. So industrial pollution, exactly what's going to happen in the industrial pollution. Okay, so what are the different types of pollution? Air pollution, water pollution, thermal pollution, and noise pollution. Okay, so this is how we categorize in main parts. Okay, so what exactly air pollution we are going to and we will be concentrated more on the air pollution only in this one, because we were concentrating on carbon capture methods. Okay, we are not going to much divert the water pollution, other parts of the pollution, but we'll be looking majorly on air pollution. So what is air basically? So basically it's a combination of majorly two gases. That is, the one is nitrogen, another one is air, and the remaining there are the subsidiary gases like a carbon monoxide, carbon dioxide, sulfur-based gases. Other gases will be present. So basically, air is consistent of nitrogen and oxygen basically. So pollution. What is pollution? How we are going to define pollution? Any substance, okay, it may be solid, liquid, or a gas, or form of energy. It's any substance or a energy, okay, such as heat, sound, radioactivity, into the environment at the rate that exceeds the rate at which it can be dispersed, diluted, decomposed, recycled, or sorted in some harmless form. Okay, so for example, if you take a water, okay, any water, drinking water, so is it a pure water? No, it is not pure water. There is some impurities, okay, but these impurities are which is present in the minimum level or accepted level. Okay, so if the accepted level it crosses, then it will be polluted, right? It will be get polluted more and more. Similarly, in the pollution means when it crosses the threshold limit, okay, it may be in the form of energy or in the form of substance. We will call that is a pollution. So comes to the air pollution. Air pollution is the contamination of air caused by the presence of chemicals in the atmosphere that is hazardous to the human and other living beings, health, or causes damage to the climate materials. So this is the one of the major challenge in India or across the world. Okay, so because every day the quality of the air is getting decreased, because we will be polluting more and more, because a lot of industries are coming up, transportation industry. So this we are going to add more and more chemicals to the air. That's the reason we are getting more pollution nowadays. Air pollutant includes such as ammonia, carbon monoxide, sulfur dioxide, nitrous oxide, methane, carbon dioxide, and chlorofluorocarbons. So these are the listed parts. Okay, in unlist the known parts. Okay, so the unknown parts still more are maybe present, but we are not known. So ammonia is very irritating and causes the brain damage most of the times. Carbon monoxide, sulfur dioxide, nitrous oxide. So these are all exactly present in the air, but when it crosses the limit, it will cause a lot of damage to the human environment or any living environment. Particles, both in organic and inorganic, particles like a small visible or invisible particles. Okay, most of the time it's invisible particles because of the small micro sizes. It may be 1 nanometer, 2 nanometer, 1 micrometer, so kind of things. So this particle also we will inhale while driving, these kind of things. Okay, and living molecules. Air pollution may cause illness, allergies, and even death in the people. This death rate is also very severe in nowadays. It can also harm other living species such as animals and food crops. It can impact the natural environment such as climate change, ozone depletion, or habitat degradation, or build the environment, for example, acid rain. See, climate change. This is the one of the big challenge what we are going to face. Ozone depletion, so it will affect the how the solar energy is interrupting the earth, or habitat degradation. So we are changing our habitations, like we are changing one place to another place because of the environment degradations. Okay, so these are the effect of air pollution. Okay, air pollution may be caused by the both human activities and natural phenomena. Air pollution is the major risk factor for variety of pollution-related disorders such as respiratory infections, heart disease, COPD, stroke, and lung cancer. So one of the best example for natural phenomena of air pollution is coronavirus, right? So this virus is natural, but it is spread through the air or small particulates, right? So this is the natural way. In human activities, this means we will be creating a lot of dust particles. We will be burning a lot of fuel. It will be generate a lot of secondary byproducts like carbon dioxide, carbon monoxide. It is going to enter into the air. Okay, so this will affect the human quality life. Okay, so what is the result of this air pollution? Growing research shows that exposing the air pollution linked to lower IQ scores. Okay, people thinking capability is decreasing because of the air pollution. Okay, decreased congestion and increased risk of psychiatric illness such as depression and poor parental health. Poor air quality has a far-reaching consequences like human health, although it is most affecting the respiratory and cardiovascular systems. So basically, air is the main food for us, right? So maybe we will be eating solid food like rice and all, but actually air is also one of the main food or main fuel for us. Okay, so that I'm going to explain further in chemical equations all. So the quality of food is affected. Whatever the thing, quality of air is affected. Automatically, our thinking capability is decreased, right? Because of this one, people are going to a lot of psychiatric illness like depressions. Okay, parents are very much worried. Okay, they will be they'll be spending more time in the outside. They will be get a lot of stress while coming back in the home, so they cannot take care of their children and all. Okay, a lot of issues we are going to see because of air pollution. Okay, so this is a simple chart. Okay, so I'm trying to explain how exactly the oxygen level for each and everything. Okay, so we have different anatomy structure, like okay, different parts like lungs, heart, stomach, okay, kidney, the intestines, everything. Okay, every organ need oxygen. Okay, so some of the just in case of example, I'm taking liver and spleen. So it is going to consume 23 watts of energy and requires 67 milliliter per minute of oxygen. Okay, so this is how every part. Okay, so we need oxygen. Okay, so oxygen is one of the main constituent in the air, but if it is the air is polluted, the quality of the oxygen also get decreased. So okay, so how we work? Okay, how our machine work? So our machine work basically based on the lungs, right? The air with respect to the air. Okay, so a quantity of X amount of air we are going to inhale. Okay, so this quantity of X amount of air inhale, so it's going to utilize from the different parts of the anatomy or body, right? So when you inhale the air, okay, instead of oxygen, you are going to inhale some of the pollutant also. What is going to happen? It is going to degrade your lungs. Okay, the first part is degrade your lungs. Second part, the quantity of oxygen required for your sustainability is going to decrease. Okay, when your oxygen sustainability decreases, your parts going to what? It's going to degrade basically. Okay, because you're not giving the proper fuel, right? When you're not giving the proper fuel, all our parts is going to degrade automatically. So this is the one type of the thing. The second thing is, what are the different types of this one is we have heavy metals also in the air. Okay, so like we have a lead, we have a mercury, we have a copper, we have a nickel, different types of heavy metals also there. So this is also affect our lot of anatomy like a headache, fatigue, okay, respiratory illness, cardiovascular illness, liver damage, gastroenteritis, skin irritation, kidney damage. So a lot of things are going to happen with respect to the pollution, air pollution. Okay, so this is the percent of BMR. BMR is basal metabolic rates. Okay, how much energy we are going to consume with respect to metabolic. Okay, so basically you can see here every part requires oxygen, and amount of it's going to generate. It's going to require a minimum amount of energy also. So when the air pollution is there, the output of this slide is when the air is polluted. Okay, we are not going to get the required quantity of air. So because of not less quantity of air, the quantity of oxygen also less or degraded oxygen level. So because of this one, our anatomies get degraded. So this is the basic equation of how we're going to get energy with respect to the oxygen and fat. Fat maybe you can consider as sugar also. Okay. So whatever we eat, rice, chapati, puri, whatever fruits, everything, it will be contain these hydrocarbons. Okay. So this hydrocarbons is going to act with oxygen. Okay. So this oxygen, what's going to release is carbon dioxide is going to release water and heat. Okay. So this heat is going to preserve our body temperature 37 degrees Celsius. Okay, so that we can work, we can execute our work properly. Okay, what happens if the basic energy equation get altered? So air pollution, because of air pollution, so this is got variated, right? So quantity of oxygen is get deprivated. Okay, because of that one, this whole chemical equation is get destructed. Okay, so when this chemical equation is destructed, obviously we will be get affected with our daily routine. Okay, so I will try to explain how exactly the Earth climate system work and energy balance is going to happen, because it's very important to understand the importance of carbon capturing in the current world. Okay, so let's see. So this is our Earth. Okay, so this is the sun. So Earth is revolving around the sun, and we have a moon also revolving. Okay, you can see. So we have a daylight and the night, right? So daylight will be 12 hours, and night will be around 12 hours in the equilateral line. Okay, so if you go the North Pole or South Pole, the amount of time exposed per day, it's going to vary also. Okay, so 43% of the total radiant energy emitted from the sun is a visible part, okay, of the spectrum. Okay, so this is the visible part of the spectrum. Okay, the bulk of the remainder lies in the near infrared region, 49%. So infrared, so this is the infrared region. Okay, so this is the 49% of this one. Okay, and the ultraviolet section is 7%. So this is the 7% of the energy what we are going to receive from the sun. Okay, and less than 1% of solar radiation is emitted X-rays, gamma rays, and the radio waves. So this is the X-rays, gamma rays, and radio waves. Okay, so less than 1%. So basically, we will be getting IR and visible. Okay, IR and visible we are going to get. That is 49%. So what is IR rays? It's an infrared rays. What kind of energy it carries? It carries the thermal energy, right? Any doubts? Is that I'm audible?
Yes, sir, you are audible.
Okay, thank you. So this is how energy also. So we can see the highest energy peak is here, right? That is in the visible range. Okay, and if you take the overall energy in the area wise, so the more energy in the infrared region also, right? So this is the maximum energy criteria in terms of thermal and visible energy. Okay, so understanding Earth's climate system and energy balance. Okay, what's going to happen with respect to sun and Earth? Okay, so sun will be emitting X amount of energy, that is 100% of energy towards the Earth. Okay, so we are going to receive this one. Out of this, 6% will be reflected back by atmosphere. So in the atmosphere will be a different particles, right? Maybe some void and some other particles will be there. That is going to reflect the sun energy 6%, and 20% of energy will be reflected back by the clouds. Okay, reflected back by the clouds. So after that, the 4% of energy from Earth surface. So some of the energy is fall on the Earth and it will be reflected back. Okay. So reflection, how much energy? 24 plus 6. Almost 30% of energy will be reflected back without interacting with the Earth. So after that, what's going to happen? So 16% of the energy will be absorbed by the atmosphere. What is the atmosphere? Again, it's air, moisture, cloud. Lot of things will be there. Okay. So that will be absorbed by 16%. So 3% will be absorbed by the cloud. So this is the reflected, this is the absorbed energy by the clouds. Okay. The 7% will be conduction of and rising of the air. Okay. So what is going to happen? 7%. So this thermal energy is going to warm the Earth surface. Okay. It's going to warm the Earth surface. So because of the warmth, the moisture will be keep on going up again. Okay. So this moisture will be go up again. Okay. Observe the 51%. By the land and oceans. Okay, the remaining 51% is going to observe with the land and oceans. Okay, so totally 64% is coming here. Okay, 6% is coming here. So radiated directly to the space from the Earth. radiation absorbed by the atmosphere of 15%, carried to the clouds and atmosphere by the latent heat by vapor by 23%. Okay, so this is how energy balance is happening from the sun to the earth. Okay, so this is same explain same picture. I'm representing different format. Okay, so to represent the clouds and earth. Okay, so in this picture, okay, so this is the picture I recently taken in the Himalayan region where I went for some work. Okay, so you can see some pattern here. Right, I will try to explain. Okay, so can you see the valley ridge here, right? So we are able to see the valley ridge here. So you can see, so there is a clouds formation along the valley's ridge. Okay, so this is empty region. So this is empty region. This is the valley region where the clouds are getting formed. Okay, so this picture is taken around 2 o'clock in the midday. Okay, so when you see around morning 7 o'clock or 10 o'clock, the whole sky is blue. Okay, there is no any clouds. But when you see around 12:30 and onwards, so there will be a formation of clouds, and around 2 o'clock we are able to see the big clouds. Okay, so what's exactly happening here? The sun rays, the IR rays directly falling on the earth surface. Okay, so this earth surface will be containing a moisture, right? The moisture, maybe earth surface or some trees, some grass, some kind of plantation and all, it will be having moisture. Water. So this will what happened? It will reject the moisture and try to evaporate along the ridges and form the clouds on the valley ridges, right? So what happened if the clouds are not formed? What's going to happen? Any idea? Why the temperature is very hot in the deserts? Any idea? In the desert, we don't have any plantations, right? So when the plantation is not there, there is not much moisture. When there is no much moisture, okay, it cannot absorb the energy and convert in the water into the vapor and throw to the atmosphere. Okay, there is no any change of phase, right? Solid to liquid or liquid to gas. There is nothing will happen in case of desert. But in case of where the green plantations are there, the plants and some other parts will be having is capable to eject some of the water content. So this will absorb the heat. Okay, so this will absorb the heat and emit the vapors. So this process will actually decrease the temperature. Okay, so this will decrease the temperature. That's why the plantation is very important for the thermal regulation of the earth. So this is how the cloud formation happens. So this indicates clearly the decrease energy absorbed to form these clouds. Okay, so actually, so this is the ideal case. Okay, this is the ideal case. So in reality, what's going to happen? So what is going to happen is man-made forcings include particle pollution, okay, which absorb and reflect the incoming sunlight, deforestation, which makes changes how the surface of the earth reflects and absorbs the sunlight, and the rising concentration of atmospheric carbon dioxide and other greenhouse gases, which decrease the heat radiated to the space, and forcing can trigger feedback to the loops and can intensify the or weaken the original event. So what it means, see, so this is the gas eruptions. Okay, so fossil fuel eruptions, this is the man-made. Okay, this is the natural, this is the man-made. Okay, so we have a plantation where respiration going to happen. See, during the photosynthesis, it will absorb the CO2, but when the sunlight is not there, it will emit the CO2. Okay, so CO2 will be absorbed in the dissolution also. Okay, again, marine deposits going to happen. Okay, so this is happen in the realistic case. So what we have to look in this one is, okay, whatever energy we received, okay, some of the energy we will be adding more energy, okay, by human activities, right? So when you burn the fossil fuel for the man-made structures or man for our applications, we'll be emitting more and more heat, right? So this is going to add it into the atmosphere. So this is the fossil fuel consumption in 2023 database. Okay, so with respect to England, okay, it's a 5%, 9, 10, 12, 12, 15, 27, 35, 76, 140, 146 exajoule. So these units are in exajoule. One exajoule is called 174 million barrels. So So we will think, okay, this is very less, this is very less, okay, compared to India. So these countries are very less. Not actually. This population and geography also very less, these countries. Okay. Compared to India, they have less population, less geography. They're very small countries. That's why they will be numbered less. But basically we need more energy. So these countries like UK, Germany, and this European Union are the any countries near to the pole side, like North Pole or South Pole, they need more energy because of it's very cold. If they want to survive, they need a proper heating system in their homes and all. Okay, so compared to the, so this is the oil percentage in India. Okay, this is the natural gas, and we are going to burn more coals here. Okay, what's going to happen in the combustion reaction? So we are going to burn hydrocarbons, going to add, okay, we will get the release of CO2, H2O on delta. This is the ideal equation. Okay, so this is the what the equation we are going to expect. But in reality, we will be getting what we will be not going, not only supplying O2, we will be supplying in nitrogen also here. Okay, so in the here we will be having other contents like a sulfur and some other thing. We will be getting other pollutants like a CO, NOx, and everything we are going to get. Okay, so basically what's going to, one more thing we have to observe here. So this reaction, okay, we will be getting air pollution is the one part. Okay, so the air pollution will be containing CO2, CO something like that, and we will be adding the heat. Okay, we are getting the heat and it is added to the atmosphere also. We have to take care of this one also. Okay, so because of this action, okay, so we will be adding more heat. Okay, how, what is the different sources of adding heat? So basically burning a fossil fuels like coal, petrol, anything. Maybe you are putting in your bike, or you are putting in your car, or you're running an industry, it doesn't matter. Basically you will be adding more heat to the atmosphere. So what's going to happen when you add the atmosphere? So you can see here, okay, so this is the North Pole. Okay, so how much ice it is going to melt, right? So you people think, we can think that, okay, we'll be burning from the long time. Okay, so still nothing is happened. So why it is this one? Anybody can answer this question? So why the temperature is not so much highly increased from the past some 20-25 years, even though we are burning so much of fuel? Okay, I will try to explain. Okay, so when you put a water cup into the fire, what's going to happen? When you place just a water cup, sorry, just a cup, a empty cup onto the on the burning fire, what's going to happen? It will burn, right? So when you when you expose any fuel, okay, even though it is a paper is a fuel, when it is burned, when it is exposed to the flame, it is going to burn. But when you add water here, what is going to happen? So first it will try to boil the water. Okay, whatever the heat transfer here, it will try to transfer, the water will be absorb that heat. After that, it will try to convert the phase change, right, from the liquid to the vapor stage. It will try to convert all the water into vapor. Then after the once all the water is evaporated, then it will start burn. Similar phase we are in. Okay, we are in the similar phase, very very similar phase. So even though we will be burning lot of fuels every day, every year, every month. Okay, so our temperature is not so much hike, but the temperature is hike, but not so much, because what's going to happen? The temperature is melting the ice right now currently, right? The latent, because of the latent heat property, the ice is melted and converted into water by absorbing that heat. Okay, because of this one, what is going to happen? The quantity of water on the earth surface is increasing. That's the reason all the coastal area is getting affected nowadays because of tsunamis and other things. So the quantity of water is increasing, hence the coastal cities are submerging through the oceans. Okay, so this is the one thing happening all over the world. uh, okay, uh, once the ice is melted in considerable amount, what is going to happen? The water temperature is going to increase. Okay, so we are not in that stage, but we are going to face that stage. Okay, so once the ice is melted in the considerable amount, the temperature of the water is going to increase. Hence, after that, the all the surrounding area, okay, every temperature is going to increase. Okay, so this is how the Earth is changing from one atmospheric change to another atmospheric change. Okay, so this is the global energy demand project for 2050. Okay, so 1918 it was like this. Okay, It's a global energy demand. Okay, 2050, it is like this. Okay, around 80 to 50, it's around 80, 70 years. In the 70 years, we will almost like a more than triple. Okay, so in that, okay, so crude oil, okay, we are planning to decrease the crude oil. Okay, but natural gas we are going to increase. Okay, so after that, coal also will be similar way. Okay, nuclear also emit heats. Okay, biomass also emits the heats, wind, solar, and other renewable energy. So this is very small part. Okay, so this can save us. Okay, this can save to decrease the adding heat into the environment. Okay, so this slide will about the Indian scenario. Okay, 2013 it was this one. Okay, it was a forecast for 2013. Okay, in 2020 it was similar to this one. 2030, 2040, the coal percentage is increasing. Means coal is like a, see, we can think that coal is like a resource for what to decrease the temperature. Okay, so here what we are going to do, we are burning the coal. Okay, we are burning the coal and making to ashes, and we are going to increase the temperature. In similar way, we can think in vice versa. If you create a coal, okay, if you create a coal more and more and buried inside the earth, we can decrease the temperature also. Okay, how can we create the coal? To create the coal, we have to plant more and more plantations. When the plantations are very bigger, just try to dig and insert inside the landscape and try to grow more and more plants. How more and more plants we are going to grow, that much of coal we can produce, and we have to bury it inside the land so that we can store the energy. Okay, so air quality index is one of the main parameter. Okay, so this is in 2022 air quality index is taken. Okay, around the Indian cities, nearby Indian cities. This is okay. So this is very much above the 200 level. Okay, about 200, 200, 200, 200, 200. This is the less than 200. Okay, so this is the average Indian polluted cities. Okay, this one is also in 200 around along the world. Okay, Bangladesh is very high. Okay, Kuwait. Okay, Emirates, India is here in the yellow, Iraq, Pakistan. Okay, when it comes to Mexico, so this is the more forest regions. Okay, Uzbekistan, Macedonia, North Korea, Turkey. This is the most forest zones where we'll be having green than this one. Okay, what exactly air quality index try to tell us? Okay, so this is the pollution from different industries. Okay, so transportation industry contribute 14%, industries 21%. Okay, other energies 10%, electrical heat production 25%, agricultural, forestry, and other land use 24%. Means we are, this is the main reason for the adding air quality index because of deforestation. Okay, if you remove the forest, it will be more and more difficult for human territories. Okay, so consumption of building again 6%. So what air quality index shows that? Okay, so green, it is very good. Sorry, good values of index is 0 to 50. Air quality is satisfactory and air pollution poses little or no risk. Okay, so yellow, moderate, it's a 51 to 100. Air quality is acceptable. However, there may be a risk for some people, particularly those who are unusually sensitive with air pollution. Okay, so orange, unhealthy and unsensitive groups. Okay, 101 to 150. Members of sensitive groups, many experience health effects. In general public is less likely to get affected. Okay, red, unhealthy, 151 to 200. So members of the general public may experience health effects. Members of sensitive groups may experience more serious health effects. Okay, purple, very unhealthy. Maroon, hazardous. So when you see this one, okay, so here are the some cities. Okay, New Delhi, Ghaziabad, Noida, Faridabad, these are above 200 or near to 200. Okay, so they are here. Okay, they are here and here. Okay, so already it's a very serious concern about this one. Okay, so we can see, okay, there is no any purple or sorry maroon. Okay, but actually maroon will be present in terms of a concentrated area where actually industry represents. For example, if you go to any industry who manufactures like a ash related work and all, they will be working in maroon, but whole city may be less, but the particular region will be on maroon or hazardous. Okay, so this is how air quality in present scenario. So where does the air pollution originate? Where it is going to originate again? So it's from the waste. What are the gases we are going to get from the waste treatment? Carbon dioxide, carbon monoxide, and methane. Okay. So farming will be lot of like they will be using the chemical. These chemicals will be reacting with the air, and it will be form some of the pollutants. And second things, during the farming activities, they are going to burn lot of agricultural waste. Okay, so this agriculture will create a dense smoke. Okay, clear combustion doesn't create smoke, but if we are getting dense smoke, means it's a partial combustion. There is a lot of unburnt gases, that is like a carbon monoxide and some other things. It is going to affect us. Okay, transportation industry, again, if it is a clear combustion, there will be no smoke, no bigger smoke or thick smoke from the vehicle. But when it's an unburned incomplete combustion, we are able to see a lot of smoke here. Works and minings, again, a lot of consumption of energy. Livestock, if we increase the livestock, obviously livestock has to inhale the oxygen and exhale the carbon dioxide, right? So this also affect water treatment plants, residential, industries, volcanoes, and combustion. Okay, so these are the main main sources for the air pollutions. Types of industrial emissions. What are the different types of industrial emissions we are going to get? One is majorly carbon dioxide. The main greenhouse gas emitted from the fossil fuel combustion in the power plants and manufacturing contributes to global warming and climate change. Okay, so methane gas emitted during the production of transport of coal, oil, and natural gas, as well as certain initial process, it is a more potent than CO2. Okay, in terms of impact of global warming. So methane, we have to burn it. Okay, when you burn, it will be converted to carbon dioxide. If you don't burn, it will be more hazardous. Okay, so what are the different sources? Like transportation of coal, oil, and natural gases. And second thing, the biomass. Okay, when biomass, we have to burn the methane completely. Okay, nitrogen oxides and gases resulting from high temperature reaction in industrial process in the vehicle combustion, they can cause respiratory problems and contribute the formation of smog and acid rains. Volatile organic components, COV, emitted from the solvents, paints, and industrial process, they are pre-successor of ground level ozone, affecting air quality and respiratory health. Basically, a volatile liquid. Okay, it automatically volatile at room temperature, it will cause COV. The other particulate matters is PM1, PM2.5, PM10 TSP, small particles from the combustion and stationary and mobile sources. They can penetrate deep into the lungs and causes cardiovascular and respiratory problems. Okay, so these are the main problems for the lung cancers. So if you go and contact most of the cancer area in the Bangalore, so lungs cancer is caused by a lot of this P1 to the TSP. Okay, so hydrogen sulfide, rotor egg odor, it's a very bad smell. Okay, released by industrial process such as oil refining at high concentration. It can be toxic and affect human health. Okay, acetose, mineral fiber used in the construction and manufacturing industry. Inhaling acetous fibers can cause the serious lung disease, including cancers. Okay, lead, heavy metal emitted by the metallurgical and battery industries. Lead exposures can adversely affect the nerve system, especially in the children. Okay, mercury, liquid metal released from the coal burning and chlorine production. It is highly toxic and can accumulate in the food chain, affecting human and animal health. So these are the main pollution happening in and around the cities or manufacturing sites. Okay. Emissions of air pollutants associated with the fossil fuel combustion. Okay. So if you take this bar chart, okay, percentage of total emissions. Okay. So CO2 100%, NOx 100%, CO 100%, SO2 less than 100%, more than near to the 90. Okay, PM10, VOC, volatile substances, lead, and air toxics. Okay, these are the combination of different pollutants. Okay, so particulate matter also we have discussed. Okay. Okay, this one. So the role of carbon dioxide in global warming. So this is the very important slide. Okay. So global warming is the long-term heating of Earth's surface observed since in the pre-industrial period between 1850 to 1900. Due to human activities, primarily fossil fuel burning, which increases heat trapping greenhouse gases level in the Earth's atmosphere, this term is not interchangeable with the term of climate change. Okay. So basically what is happening here, if you see the graph here, it is at 1880, 1900, 1920, 1940, 1960, 1980, 2000, 2020. So here you can see the graph is like this. Okay, this is the percent of CO2. Okay, so after 1940, there's a lot of peak, then we keep on increasing. That means the emission of carbon dioxide will keep on increasing from year to year linearly. Okay, so there is a one great sentence from the Dr. James Hansen. Okay, what he told is, if humanity wishes to preserve the planet Earth similar to that on which civilization developed and which life is Earth is adapted, means the whatever Earth we are seeing with the civilization, if we want to preserve it as the civilized Earth, okay, so pale climate evidence, the ongoing climate change suggests that CO2 will need to be reduced from current levels to at least 350 ppm. What is the current level? If you go to the current level, it's a 420 ppm, and we want to decrease to 350 ppm. Okay, so this, if we don't decrease, what exactly happen is we are not able to emit back the what is the solar energy or heat energy received from the Earth. Okay, so when we are not able to receive it back, the Earth energy is accumulated in the Earth surface more and more. So temperature, it may be result in the higher temperatures as soon as possible, where the generation of us, we are not able to sustain more and more. Else we have to change our the sustainability, or we have to change something else. Okay, so hence carbon dioxide is very important with respect to the global warming. Okay, what exactly global warming? Okay, when sunlight reaches Earth, the Earth's surface absorbs some of the light's energy and radiates. It is infrared waves, which we feel as a heat. So these infrared waves travel up into the atmosphere and will escape back into the space if unimpeded. So what's going to happen is, whatever the energy we receive from Earth, okay, it will reach the Earth here. Okay, after a certain time, it will go back. Okay, go back to the space. Okay, so if it doesn't go back, obviously the heat will be trapped here. Okay, so oxygen and nitrogen don't interfere with the infrared waves in the atmosphere. Okay, the presence of air, that is basically the oxygen and nitrogen doesn't have much effect while sending the back these infrared waves. Okay, uh, the that's because molecules are picky about the range of wavelengths that they interact with them. Okay, for example, oxygen and nitrogen absorb energy that has tightly packed wavelength of around 200 nanometers or less. Okay, so oxygen and nitrogen will absorb energy which have a small wavelength. Okay, so that is 200 nanometers or less, whereas the infrared energy travels a wider and lazier wavelengths, 700 to 1 lakh. Okay, 10 lakh nanometers. Okay, so 700 to 10 lakh nanometers, those range don't overlap with respect to the nitrogen and oxygen. So that oxygen nitrogen, it has the infrared waves don't even exist. Okay, they let the waves and heat pass freely through the atmosphere. So hence the effect of presence of oxygen and nitrogen doesn't cause any global warming. Okay, Earth transforms sunlight into the infrared energy. Greenhouse gases like carbon dioxide and methane absorb the infrared energy. So other than this one, oxygen, nitrogen, there is a greenhouse gases, that is a carbon dioxide and methane. Okay, absorb the infrared energy, re-emitting some of them back into the lower surface. So in this CO2, H2O and CS3, what's going to happen? It will absorb the energy while going back, and it will push us back to the Earth surface. Okay, so this is how Earth surface is going to warm and warm because of the pollutions. Okay, so this is again the light spectrum. Okay, X-rays, UV, visible, infrared, microwaves, and radio waves. Okay, so carbon dioxide absorbs energy that is variety of wavelengths between 2000 to 15,000 nanometers. Okay, so basically here we are able to see the infrared wavelengths are 700 to 10 lakh nanometers. Okay, and um nitrogen and air oxygen will be having a 200 nanometers, so it doesn't affect here. But 700 to 10 lakh, so we can able to see here 2000 to 15,000 nanometers. So carbon dioxide will absorb the energy. Okay, will absorb the energy while going back these energies, and it will reflect back this one. Okay, as CO2 soak up the infrared energy, it vibrates and re-emits the infrared energy back in all the direction. About half of that energy goes into the space, and about the half of the returns back to the Earth's heat. contributing the greenhouse effect. Okay, this is the unsymmetrical stretch of a carbon molecule. Okay, this is symmetrical stretch. Okay, symmetrical. This is the vertical band. Okay, this is how the carbon molecule vibrates with respect to when it is soaked inside the infrared energy. Okay, greenhouse gases such as a carbon dioxide are good at absorbing infrared radiation that is heading from the earth toward the space. When the absorb energy, the molecules heat up, rotating and vibrating more. They also bang into one another, releasing energy. This animated diagram illustrates the different ways of carbon dioxide molecules vibrate and rotate when they absorb the energy. So this process heat up the atmosphere. So this is how the bouncing happen and it will release the energy to the atmosphere. Okay. Any doubts with respect to this slide? I hope I'm audible, right? Am I audible? Hello? Anybody? Am I audible? Am I audible? Is anybody there? Yes. Okay. Fine. Okay. Okay. How to avoid CO2 emissions? So, what's the best way to avoid the CO2 emissions? So, transportation, drive less. When you do plan ahead to make the most of your trips, you can also walk, bike, take public transport, carpool, or use the. Means basically we have to decrease the fuel consumption. Okay, how can we decrease the fuel consumption? Help each other, drive less. Okay, these kind of activities actually decrease the usage of fuel. So second one is energy. Use renewable energy sources like a solar, wind, and hydropower. You can also check the energy labels and use the air conditioning responsibly. So basically, use the live energy. What is live energy? What is the energy you receiving right now from the sun? Use that energy. Okay. So these fuels are basically fossil fuels are basically a stored energy. It's not a live energy. It's stored energy. It's actually received long back from the sun and it is stored already. So when you use that stored energy, we'll be emitting more and more pollution at lively and heat also. Okay, that's why we have to go for the renewable energy sources. Okay, food, buy fresh instead of storing and all, buy fresh, so we can save more energy. Local produce instead of transporting long distance, producing locally. Okay, business, choose sustainable suppliers and impose CO2 caps and company cars choices, etc. Shipping, optimize the routes to avoid the wasting fuel. Other, plant tree, calculate your environmental footprint and adopt circular economy habits. Okay, this is very important part. The only way, natural way to decrease the CO2 is photosynthesis. Okay, photosynthesis. So carbon dioxide react with water in presence of sunlight. It will be converted into the stored energy pack, that is a plant. Okay, you can store the plants after using that one and oxygen. Okay, so actually this is the one of the bank. Okay, where we can store the sun's energy and increase the life of the earth. Okay, so hence try to plant at least some of the plants at least. Carbon capture and storage. Okay, so till now we have discussed importance of carbon dioxide in the environment and all. So how the way of decreasing and all, but in present situation, as we see the graphs here, okay, so these graphs here, we have to burn the energies, right? There is no any other option. If you want to sustain, or if I want to sustain, I have to burn some energies, stored energies. What can be done right now? So that is the carbon capture principle schemes here. Okay, so carbon capture is like that. So whatever, whenever the industries are there, okay, it is going to emit a lot of carbon dioxide or any other things. What we are going to do, we will extract the carbon dioxide from the process and we will compress it and we will bury it in the earth. Okay, we are going to bury in the earth. So this is the basic principle of carbon capture. Carbon capture and storage is the way of reducing carbon dioxide emissions, which could be the key helping tackle global warming. It's a three-step process involving capturing the CO2 produced by a power generation or industrial activity, such as hydrogen production, steel, or cement making, transporting it, and then permanently storing in the deep underground. Okay, Carbon capture storage has been operating since 1972 in the US, where several natural gases plants in Texas have captured or stored more than 200 million tons of CO2 underground. Carbon capture utilization and storage finds productive usage of trapped gas. Okay. So basically what is going to happen, whatever we cover the gas chambers in inside the one, so they act as a membrane. Okay. So whatever we do, okay, maybe after certain years, okay, we may start experience the leakage of CO2, and at a sudden we will be having more CO2 in the atmosphere. That is the one drawback we are going to expect. Okay. So carbon capture methods and techniques. Okay, one is absorption method, cryogenic method, membrane suppression, adsorption, chemical looping. So in the absorption again, chemical absorption, physical absorption, like amines, okay, ammonia and other things. Physical absorption like a rectisol, Selex, pure cell, ionic liquids and otherwise. Okay, cryogenic membrane suppression again, gas suppression, gas absorption, ceramic membrane, polymeric membrane, hybrid membrane. So these are different membranes we are there to extract the CO2 from the exhaust. Absorption method, chemical absorption, physical absorption again. Okay, similar way, activated carbons to all the different metal oxides we are going to use as a absorption method. Chemical looping, calcium looping combustion, metal oxide, iron, manganese. So these are the metal oxide we use for the chemical looping. So this is just a block diagram. What are the different techniques exist in the CO2 capture? Okay. So one of the method is pre-combustion method. So what are the major things we require for the combustion? Fuel and oxygen, right? So fuel will be supplied here. Okay, oxygen will be supplied here along the steam. What is going to happen is, so when the gasification is added here, means we are going to supply the heat along this one. So there is a formation of CO and H2. Okay, so CO and H2 will be there. Then water is injected in the water gas shift. Okay, WGS. So what is going to happen is, CO is converted into CO2 and hydrogen. Okay, CO2 and hydrogen separation is going to happen here. So from this separation, we are going to separate the CO2. We are going to separate the H2 also here. The CO2 is compressed. Compressed CO2 will be buried in the land. Okay, so this H2 combustion chamber, power generation, heat and electricity, we are going to get the air here, and we are going to get the water as the output here. So this is how one of the method of CO2 extraction before combustion. Okay, so combustion is happening here. So integrated gasification combined cycle. Okay, IGCC. So in this case, what's going to happen? We are going to supply the fuel here. Okay, steam, oxygen. So fuel we have to see, because this is the containing hydrocarbons. So where is the carbon is there, then there is a positive formation of COR, CO2. Okay, so what's going to happen here is supplied here. From the air, oxygen extracted. Okay, nitrogen separated here. So in the gasifier, what's going to happen? So we are going to supply the heat. The slag will be removed as syn gas. So we are going to generate. That is a mixture of fuel, steam, and oxygen. We are going to get it here. So then we will supply to cyclone separator. In the cyclone separator, what's going to see? We are going to get the CO2 and H2S here. Okay. So this CO2 and H2S again we are going to WGS, water gas shift. Okay. In this WGS we are going to generate CO2, H2, H2S. Okay. So the steam is separated here also. CO2, H2, H2S. Okay. Here desulfurization unit, we are going to remove the sulfur here. So sulfur is removed. We are going to get CO2 and H2. Again CO2 separator here. We are going to CO2 extraction here and storage. The hydrogen will be supplied to the combustion chamber, and we are going to run the turbine or utilize the hydrogen fuel. So this is the IGCC. So next is post combustion method. Okay. So previously we are trying to extract the carbon dioxide before the combustion. Here we are going to extract the after combustion. Okay. So fuel combustion chamber in this year we are going to supply the flue gases. The flue gases basically the burnt gases, power and heat. We are going to generate the flue gases, DNOx, DSOx, dust removal, then CO2 capture, treated flue gas. Okay, CO2 compression, and it will be buried in the underground. Okay, electricity generation, heat production through the use of post combustion CO2 capture method. Okay, so the other one is scheme of post combustion CO2 capture method using a chemical absorption method. Okay, here basically what's going to happen? This is the flue gases. This is the observer. Okay, this is the treated glass. Lean loading solution here is coming here. Rich loading pump. This one here. So this is going to be our heat exchanger here. This is the cooler. Okay. So once each exchanger is there, so we are going to supply the machine to stripper. So in this stripper, what's going to happen? We are going to condenser here. Again, this is cycle unit. We are going to extract the CO2 and compress, and we are going to bury this one. Okay. So here, what is going to happen? We are going to get the fuel. We are going to use it, and we are going to supply back the CO2 here, in the stripper. Basically, we are going to extract the CO2 through the stripper. Again, it's a membrane process. Membrane process, we will be having a wet scrubber, flue gases, okay, cooling water, compressor. So there is a membrane, okay. So this membrane will be like high pressure and low pressure, okay. Flue gases, steam on the absorbent, okay. So basically, during passing, just it will extract the CO2, and we're going to bury it in the collect and compressed and buried in the underground. So oxy-combustion method, again it's a combustion chamber, fuel, air separator unit. Okay, here we're going to get CO2 and H2O again. Power plant and heat in the electricity utility. CO2 and H2O is here. CO2 and H2O separation, H2O is separated. CO2 compression of CO2 and compress CO2 into the cylinders and bury inside the ground. So this is different methods of combustion, this extraction of CO2, and we were going to put inside the ground and make it like a less CO2 in the atmosphere here. So commercial CCC facilities operating under the development. Okay, in 2010, this much of facilities like around 90, but in 2021 it was increased to almost like a 180 facilities. Okay, so this is how CCS is advancing towards to reduce the global warming. Okay, so just it's an overview representation. CO2 capture where from the industries, transport and bury inside the storage. So this is what I'm going to, I was worried, like when we buried here, okay, when we buried here, so it acts like a membrane again, okay. We don't know when it is going to explode or when it is going to extract the CO2 into again back to the atmosphere. When it is suddenly happen all together, so it may be a serious concern for the existence of human life at certain stage. Okay, so this was my small presentation about the CO2 and all. So any doubts?
Yes, sir. Dr. Praveen, sir.
Yes.
Thank you for a very nice informative presentation.
Okay.
Most important, it's a pictorial presentation, all the graphs and images. So it is very interesting for all participants. So I think today most of the participants knows very well how to do the presentation or how to make a presentation, informative presentation. So that is actually nice for from your presentation. So now I would like to request all the participants. The forum is open for the discussion. We are having with us Dr. Praveen sir. So you are having the good chance to interact with the Praveen sir. So if you're having any question, you can unmute yourself and ask or discuss with the Praveen sir. Yes, please. Or if you want if you have any queries or any questions, you can write in chat box also, no problem. Or you directly ask to the sir by unmuting yourself.
So it's very important to raise some questions so that I will also find some research gap. At least I can also look in further where I am falling down.
All the topic in your presentation from the automation material and how the carbon is going to emit from the processes from the various industries like construction and manufacturing. Then from started to basic, from pollution, then air pollution, oxygen consumption, energy equations, then the different climate system, fuel consumption, type of industries, emission, then role of carbons, carbon dioxide and global warming. So I think you cover all the topics nicely. So I will share your detail with the participants. So meanwhile, if they are having any interaction in future, so they will contact you. Okay.
Yes, that is the most welcome time. So
Yes,
even I like to interact with people because like I can also think only in certain way. When somebody will interact, okay, at least I can open my mind in some other way also. So this will be input for me. So so kindly knock me at any time. So it doesn't matter to me. It's like I will like to interact more and more to at least I can contribute something more about these things.
Yes, sir, definitely, sir.
Yeah.
So with this, from the organization team of this FDP, I would like to express my sincere thanks to Dr. Praveen sir for accepting our invitation within a short period of the time and delivering the nice session on the carbon capturing and mitigation of pollution of their for the industries. So thank you once again, sir.
So please share some email. Somebody is asking some the
Dr.
link
Bilal,
and all. So
yes.
my email ID is I think I can write it here. So I will be active in email, not the LinkedIn's basically.
Okay.
So you can mark me here, no issues.
Yes, yes, yes.
Yeah.
Dr. Praveen, thank you for your valuable time.
So I will definitely thank the organizers and the participants here to they have given their precious time here. So at least I think it was like a nice session to interact with you guys and thank you. Thanks to all.
Yes, sir. Thank you, sir.
Yeah. Okay. So can I log it out?
Yes, sir. Yes.
Okay. Thank you.
Dear participants, now I will going to post the feedback link for this session 2 in our WhatsApp group.
Sir,
Please to SS.
sir, there's a one thing that each time we need to fill everything, email ID, name, and all that.
Yes, yes.
Can we edit that thing?
Sorry.
So can we edit that Google form? Because every time we need to fill again the same details.
Sir, it
Mobile
will
number,
take, sir, it
email
will
ID.
take hardly 2 minutes, sir.
No problem.
Yeah.
That's not the problem. We can do
Because
that.
we'll have the record for the
Okay, sir. No problem. If you
official
insist, no problem.
Thank you, sir.
So I request to participants fill that feedback form. So it will be helpful for us for the next process. So tomorrow we are again having the same timing, the 2 sessions, 6 p.m. One session, and 8 o'clock we are having the another session. So it's request to participants, please join before 5 minutes. So it will be helpful for the starting the session within a time. So we will log out now. I will post the link in the WhatsApp group.
Thank you, sir. Good night to all.